Good afternoon. Welcome back to the gaseous state of the this thing. Then yesterday we have seen molecular theory of the kinetic theory of the molecules, ideal gases. So the equation we have seen already: PV equal to 1/3 m n urms square. Now we have to verify whether this theory, whatever we have said, is holds good for the Boyle's, Charles, and Avogadro laws and all this thing. First law we will see as a Boyle's law, whether it is accepting the Boyle's law or one and the same or anything is different. Now PV we can write as 1/3. I am writing as a 2/3. N I am taking out, and 1/2 same thing only I am rearranging. 1/2 cancel, it is nothing but 1/3 only. So m urms square. So if you see m is a mass and u is the velocity, RMS velocity, mv square is nothing but kinetic energy, half mv square. So if I am writing this, PV equal to 2/3 n ke, that is nothing but kinetic energy. So if this is PV, if I am bringing V this side, 2/3 n ke and 1/v. At constant n and at constant temperature is directly proportional to kinetic energy. All these things will be constant. So P is inversely proportional to V. That means it is holds good for Boyle's law at constant n and t. Okay, fine. Second, Charles we will see. Same thing. PV equal to 2/3 n ke, we will write directly n/3 ke, and V equal to 2/3 n/p ke. Now what is the Charles law? V is proportional to temperature directly. Kinetic energy is proportional to temperature. So that implies V is directly proportional to this. All n/p at n constant is temperature at n and p constant. Charles law is holds good. Nice. Then we see Avogadro. What is Avogadro? Then two gases we take. P1 V1 equal to, you can take 1/3 or same thing 2/3 n1 ke kinetic energy, and P2 V2 another gas you take 2/3 n2 ke. Now in the Avogadro law, what is that? At constant pressure and volume and temperature, if you take all these things, n1 equal to n2, this is equal to this one, so n1 equal to n2 at constant temperature and pressure. When the two gases volumes are same, the number of molecules is equal to same. So our kinetic theory of molecules is nothing but the same as all the three's combination. It is only the rechecking of the once again. Now we will see some small problems, then we can see Dalton law and Graham's diffusion. Dalton law is same, just but it's very simple. That is total pressure equal to partial pressures of individuals. Tomorrow we will see the Graham's law of diffusion and the molecular these things. Then triple point and compressibility factors and critical temperatures and all that. Now we'll calculate small problems, but small twist problems. Twisting up small twisting. Now the question is, calculate the temperature at the 4 moles of gas occupying d cube at 3 bar. This is a simple this thing offline. Calculate the temperature. T equal to how much? N number of moles equal to 4, and V equal to 5 dm cube. Always remember the dm cube is nothing but a liter, and P equal to 3.32 bar atmosphere, one and the same. Now what is the temperature? So we know that PV equal to nRT. Now here he is asking the T equal to PV by nR is nothing but P equal to 3.32 mole, 3.32 bar, V equal to 5 liter, and N equal to 4 number of moles, and R equal to 0.083. This is nothing but 50. That is 50 degree Kelvin. Very simple one line question over the end. Now the next question is they calculate the total number of electrons. It is a tricky question, but it was very simple, but it is a tricky. Calculate number of electrons to be calculated in 1.4 grams of nitrogen gas, dinitrogen gas. Now he is asking. So now we know that at temperature, at SCP temperature and all, nitrogen molecular weight is the 214 jar 28. That means 28 grams. That means 1 mole. 28 grams of nitrogen contains 6.023 into 10 to the power 23 molecules of nitrogen. Always remember that whatever we are talking, the same thing will be there. At 28 grams, it will be the, if another mass, molar mass, that will be that molecules, not the electrons or protons. Now, but nitrogen gas itself is equal to 1.4 grams only. Then how much it is? 6.023 by 28 into 1.4 into 10 to the power 23 is the number of into. How much it will be? 14. It is 14 2s are 28. That means 20. 6.032 also if we are removing, it is 22. That means 6.033 by 2 into 10 to the power 22 number of nitrogen molecules. But asking the question is how many electrons are there in this. Say for each nitrogen, irrespective of this thing, each nitrogen will have 7 electrons because atomic number is 7 electrons. Then N2 means it is 14 electrons. For nitrogen, each nitrogen molecule is 14. This many molecules are there of this. So 6.023 by 2 into 14 again into 10 to the power 22. That is that many number of electrons. That means if it is 7, 4, 6 is 42, 4 point means around 4.2 into 10 to the power 23 electrons. This is a very simple question, simple answer. But only the confusion is electrons and all. Then one more, say the diffusion question. Ammonia gas diffuses through a fine hole at the rate of 0.5 liter a minute. Under the same conditions, the rate of diffusion of chlorine gas is how much? See, R ammonia is given as 0.5 liter per minute. Right. Now R chlorine is asking how much. We have the equation R ammonia by R chlorine equal to M2 by M1. Means M chlorine by M ammonia. M is a molar mass, molecular mass. So M chlorine equal to 71, M ammonia equal to 3 plus 14, 17 under root. That is nothing but 71 by 17, 17 4s are 68 roughly. That means around 4. That root under root equal to that comes to the value of the 17. This will be the rate of diffusion of this value. Find out X. R ammonia by RCl equal to X. So now we want RCl2 equal to R ammonia is 0.5 liter by X value. That comes to, I calculated as 0.25245 liter per minute. Very simple. Or R ammonia by R chlorine, the value will come. That R value, R ammonia value is already given, so R chlorine is to be found out. Okay. Okay. Tomorrow we will see some more problems and all. Thank you very much, and other things also. 10